Hi there and welcome to Penguin Learning. In this National 5 and GCSE Maths lesson, today we are going to have a look at something called completing the square. We are first going to address what is completing the square when we have a quadratic function. We're then going to have a look at the process of completing the square, so the steps that we can follow in order to transform a quadratic expression into one where we have completed the square. And in the process of doing all this, we're going to go over several examples so that you can follow us along at home. So, let's get started.
Ooh la la!
So in the lessons we've had on factorising trinomials, what we had was a quadratic expression or a trinomial which had three terms, and one was an x squared, one was x, and one was a constant or just a number. And the way we factorised it was by seeing which two terms could go in each pair of two brackets. And the way we would do that is by thinking of the numbers or the factors that go into the first term and also the last term. Okay, so for the first term we only have x and x, so for the two constants of that it'll just be 1 and 1. And then for the final part, the c part, in the form of ax squared plus bx plus c, the c would be equal to minus 11, and the only two numbers that multiply together that give minus 11 would be minus 1 times 11 or 1 times minus 11. Okay, and then what we had to say was, when we did the cross multiplication between the factors of the first term and the third term, what we had to do is have the sum of the cross multiplication equal to minus 6 here. But we can see that for any combination, if it was minus 1 or 11, doing the cross multiplication, we're going to have 1 times 11, which is 11, 1 times minus 1 is minus 1, 11 minus 1 is 10, and then if we do it the other way, we're just going to end up with minus 10. So we can see any combination of doing that doesn't allow us to put this expression into brackets. And if we can't put the expression into two brackets, we can perform something called completing the square. Okay, and we can perform this if we have a trinomial or a quadratic expression, and it means putting the expression partially into brackets. So not the full thing like we had the last time with two separate brackets, but we can put it partially into a set of brackets. And also, putting in this form known as completing the square will allow us to solve a quadratic equation as well. Now what I mean by a quadratic equation, just an equation that's in the form of ax squared plus bx plus c, so in the form prior to performing the trinomial factorisation. Okay, but what does this mean? What is completing the square of a function? Well, what we're doing is transforming a function in the form of ax squared plus bx plus c with the constants a, b, c into this form we see here, and this is where we get the name completing the square. So what we do, we put part of this expression here into brackets, and this is like the full thing squared, and then completing the square requires us to add an additional constant in order to create balance within the function. And in order for us to put it in this form, what we have to calculate are the two new constants, which are d, the term inside the bracket and is being squared, and e, the term outside the bracket, which completes the function and allows the balance. So we're going to begin by going over an example to explain how we do this. So here we have the function we said, x squared minus 6x plus 11, and this is a function that cannot be factorised, but we're going to attempt to complete the square or put it in this form that we identified up here. Okay, so step 1, in order to complete the square, we have to check the a, b and c values. In particular, what we're concerned with at the beginning is the a value, so the value before x squared. Because we don't have one here, that indicates that the a value is just equal to 1, and that's the first thing we have to check first of all when completing the square. But let's say for instance we had a 3x squared, a 2x squared, just a number that's not 1, then what we have to do is divide through by a. So if a is 3, we have to divide through by 3 for each of these three terms, and doing that will make the a value 1. But in this case we don't have to worry about that just now because a value is 1, so that's the first step complete. Step 2, in completing the square, we have to write out the brackets and get the d term, so this term right in here. And the way we get the d term is by the following equation. We can say that d is equal to b divided by 2a, and I'll explain why this is the case in just a little moment. And because our b term is minus 6 and the a term is just 1, that means d is equal to minus 6 divided by 2 times 1, which is just minus 6 divided by 2, and that would equal minus 3. And now, since we have this d term, that means we can fill out the brackets which we have up here. Because d is minus 3, we can write out in the brackets we have x minus 3 all squared. Now this is the reason that we had step 1 and step 2. Step 1 we said a had to be 1, and this d value is equal to b divided by 2a. The reason that's the case is because let's say we wanted to multiply out this set of brackets. What we would have would be x squared minus 3x minus another 3x, which would be minus 6x, and then 3 times 3 is plus 9. And you can see that the first two parts of this multiplied out gives us x squared and this minus 6 up here. And that's why we want to divide this value by 2 that we have on the bottom here, and then that's also why we wanted the a to be 1. So there's no coefficient to the x squared term, and it can be put in the brackets in this form. But you see here, when we multiply out this bracket, we end up with a constant of 9 at the end, but we want a constant of 11. And that's where up here, the additional e constant comes in to allow us to complete the expression and make it the same as our original one up here. And this is where step 3 comes in, where we want to find the e value by balancing out the constants. And the way we do this is because this as itself equals this here when multiplied out, x squared minus 6x plus 9, but we want x squared minus 6x plus 11. So that means what do we have to do? Well, because 11 is 2 times bigger than 9, what we have to do is add on a plus 2 to that function there, and that means this full thing would be equal to x squared minus 6x plus 9 plus this other 2, and that gives us the original term here. So as we can see, what we've just done there is complete the square for the function x squared minus 6x plus 11 and put it into the form, all brackets, x minus 3 all squared plus 2. So again, just to recap the steps, step 1 we want to make sure the a value, so the number before x squared, is equal to 1. In this case it was, but if it's not, then we divide through by that value. So if it was 3, we would divide each of these terms by 3. Step 2, we write out the brackets and get the d term, and this d term in here was minus 3, and we calculated that by dividing b by 2a. And the thing is, if the a value is already 1, and which we wanted to do before, this value here is just simply half of this value up here. Why do we want that? Well, because when we go to multiply out this set of brackets, what we're doing is minus 3x twice, and doing that gives us the minus 6x, so that's what we always do here. And then the final step is we have to find the e value by balancing out the constants. So we knew when we multiplied out this bracket, we get a constant of 9, but we wanted 11, so all we had to do is simply add in a 2 at the end. So let's try another example. Let's say we have the expression x squared plus 10x plus 7, and we want to complete the square of this function. Straight away we know that the a value is 1, the b value is 10, and the c value is c in the form of ax squared plus bx plus c. So the first step we want to look out for is making sure the a value is 1, which it is because we just have x squared, so that's fine. The next thing we do is want to write out the brackets and get the d term. So we're going to have something in here with x as the first term and something squared, and d is equal to 10 divided by 2 times 1, and that just gives us 5. So that means what we have in the brackets is x plus 5 all squared. And now we have to do step 3, is finding the e value by balancing out the constants. So what we have to do is multiply out the brackets, and we know that x plus 5 squared is just the same as x plus 5 times x plus 5, and that will give us x squared plus 5x plus another 5x, which is 10x, and then finally 5 times 5 gives us 25. So comparing this to this, we can see that the first two terms are correct, but what they have, the constant at the end, are different, so that means we have to correct it by adding in the e value. Because we know already this gives us 25, but we want is 7, so that means we have to take away a value that's going to give us 7. And the way we can do that is just 7 minus 25, and that's going to give us a value of minus 18. So that means now that if we put minus 18 on the end of this, we do this at the end, 25 minus 18 will give us the 7 here. So that means this here is the exact same as this up here, but now what we've done is completed the square and put part of the function into brackets, and then what we have is this constant at the end here. So we have x plus 5 all squared minus 18. So that means both step 2 and step 3 have been completed as well. Okay, let's give this example a go without looking at the steps. So we have 4x squared minus 12x plus 20. We want to put this quadratic expression into the form of completing the square. Okay, so step 1, what was it again? Well, the first thing I like to do is write it out in the form ax squared plus bx plus c, and we can see that a is 4, b is minus 12, and c is 20. And we said that for step 1, if a is bigger than 1, so in this case it's 4, then what we have to do is divide through by this number so that we have a in the form of just x squared. So that means what we have to do is divide each of these terms by 4. And then doing that, what it's like saying is taking 4 out as a common factor. But instead of putting everything in the brackets, so 4x squared, 12x and 20, I'm only going to put the first two terms in because it's only the first two terms that we're really concerned about with the bracket squared part of the function. So what I'm going to do is put in the first two terms, okay? So 4x squared minus 12x. 4x squared divided by 4 is just x squared, and minus 12x divided by 4 would be minus 3x, and then that means we can just leave the plus 20 outside of the brackets, because if we multiply out the brackets now, we're just going to get 4 times x squared, which is 4x squared, 4 times minus 3x is minus 12x, then we just have this plus 20 outside of the brackets. Okay, for step 2, what we have to do then is figure out a way that we can put this terms into the brackets squared, or in other words, we have to figure out what this d term is if we want to put it into a brackets squared part, which we said before is equal to b divided by 2a. We know that b is minus 12, 2 times a, which we said was 4. So therefore we have minus 12 divided by 8, which is the same as minus 3 divided by 2, and that just gives us an answer of minus 1.5. And although you can use this formula, d is equal to b divided by 2a, what you can do is just simply look at the bracket here and see the term is minus 3, and the d term is always just half of this term here. So half of minus 3 just gives us 1.5. But this here is the proper equation that we can use, but the easier way is just by looking at minus 3, dividing it by 2, gives us minus 1.5. So then that means this part of the function, the a brackets x plus d all squared, is going to become 4 bracket x minus 1.5 all squared. Now the final part, step 3, what we have to do is figure out what this e value is going to be equal to. And the way we do that is by balancing out the expressions, or in other words, finding out what the constant is in this term here when we multiply it out, and making sure or adjusting it so that it's equal to 20. So let's multiply this out here. We're going to have 4, and x minus 1.5 all squared is the same as x minus 1.5 times x minus 1.5. That's going to be equal to x squared. Then we have minus 1.5x minus another 1.5x, which combines to give minus 3x. And then the last two terms, we have minus 1.5 times minus 1.5. A minus times a minus is going to be a positive, and then 1.5 times 1.5 gives us 2.25. And then multiplying the entire thing by 4, so we're going to have 4x squared, 4 times minus 3 is minus 12x squared, which is the first two terms at the start which we wanted, but now the constant is going to be this 4 outside the brackets multiplied by 2.25, and that's going to give us a constant of 9. So because we know that this thing here is equal to 4x squared minus 12x plus 9, but what we want is 4x squared minus 12x plus 20, that means we have to add an additional number onto this so that it's equal to this up here. So we're going to have 4 brackets x minus 1.5 squared, and to make it equal to 20, well, what we have to say, what's the difference between 9 and 20? We know that 9 plus 11 is going to equal 20, so that means what we can do is add on 11 at the end here. We add on 11 to this, and that gives us the same expression up here, 4x squared minus 12x plus 20. So that means if we look at the general form for completing the square, a brackets x plus d all squared plus e, we can see that a is equal to 4, d is equal to minus 1.5, and e is equal to 11. Just one last thing I want to touch on before we finish on this lesson is why we would ever want to have a quadratic expression in this form in the first place. Well, basically, for those quadratic expressions which we cannot factorise, if we complete the square, then that will allow us to solve a quadratic equation. What I mean by that is if we have a function like the one above, but we say it's equal to 0, if we put it in the form of completing the square, however, that will allow us to solve for x by a little bit of rearranging the equation and then changing the subject so that we have a value for x by itself. But we'll leave that for another lesson. But all you just have to know at the moment that if we put it in this form for completing the square, that will allow us to solve for these type of equations which we cannot factorise. Okay, so let's have a quick recap on this lesson we had on completing the square. So sometimes we have quadratic functions which cannot be factorised, and we said that if we do factorise a quadratic function, that can help us sometimes solve for an equation. But to solve a quadratic function which we cannot factorise, what we can do is put part of the function in a bracket squared, and this is what we call completing the square. So we said that if we have a function in the form of ax squared plus bx plus c, then what we can do is put it in the form of a, then inside the brackets we found out another term which was called d, where we would have x plus d all squared, and then we would have to figure out an additional constant e which would help balance it out so that this expression here is also equal to this expression here. And the way we put it in this form was by following these 3 steps. Step 1 was making sure that the a value, so this value here, was 1. If not, then we had to divide through by a so that we would have to factorise a certain part of it and have a outside of the brackets. Step 2 involved us figuring out the d term, and we said that could just be done by doing the equation d is equal to b divided by 2a, and that means we completed this part in here. And the last part, what we had to do is find the e value by balancing the constants, so this value here. And the way we did that was what we had to do is multiply out the new section of the bracket, so x plus d all squared. We had to figure out which constant it gave us and then compare it to the c value we had here, and then we had to adjust, either add on a number or take away, so that what the resulting constant was here was equal to the constant we had here as well. So I hope this lesson on completing the square has been helpful to you, and if that's been the case, please give the video a thumbs up and subscribe to the channel for future content. But if you're still unsure on anything we touched on in this video, drop a comment and I'll get back to you as soon as possible. As always, thanks for watching, and I'll see you in the next video.